Fusion Mobile, quality e-learning experience on the go.
Welcome to Fusion Mobile e-learning clinic. My name is Sonia Laolua and I've been walking you through the physics course. Let's talk about magnetic field. In this topic of magnetic field, we're considering the concept of magnetism, the theory of magnetism, the Earth's magnetic field, and we'll discuss electromagnets. So, we've talked about magnets in a lesson before now. I'll say magnet is a metallic object which attracts other metallic objects. We have discussed that magnets do have, they are made up of tiny magnets, because if you keep cutting a magnet into two, you will keep getting you get a fresh magnet each time. But in this particular lesson, we'll be looking at the concept of magnetism, the concept of magnetic field. Yes, what is a magnetic field? A magnetic field is a region or an area where the magnet's force or the presence is felt. Before now, we talked about fields, and we said fields there are two natures in which force do exist. It can exist as a contact force or as a field force. And we said field forces are restricted to certain conditions or certain phenomena, such as magnetism, electricity, and gravitation. So, in this particular one, we're talking about magnetism. What do we refer to? What do we classify? How do we describe the magnetic field? It is described as the zone or the region within which the presence of a magnet is felt. When a metal finds itself, when a magnetable metal finds itself within that region, it would be attracted towards the magnet. And to be attracted towards the magnet with the force F equals QE plus QB sine theta, QBV sine theta. It will be attracted towards the magnet with the force F equals to QE plus QBV sine theta, where F is the force of attraction, Q is the charge possessed by the material, E, that's the electric current that is available to the system. We also have B, which is magnetic flux, V, which is the velocity, and sine theta is an angle between the B and the body. So, in a convention, we also have talked about the diagram of what happens in a magnet. We say like poles attract, unlike poles repel. Just the same way we have in charges, we also have in magnets. We have a positive and a negative. Only that, yeah, they are not called positive and negatives. They are called north. That's the north seeking pole and the south seeking pole. While one of them, of course, you find both of them in one bar of magnets. Find both the north and the south in one bar of magnets. So we have our magnets generating its field. Something like this. So if we should have this, what the magnetic field is what it will look like, and the charges flow while this one so if we should have unlike poles, the appearance of unlike poles coming close to each other, you have, say, this is a south pole and this is a north pole. Of course, the interaction will be an attraction, because this one wants to fly away and this one is willing to accommodate it. So there will be a kind of a bond between them. This one is willing to fly away, this one is willing to collect. But when we have two norths or two souths, then we have opposition. So since they are not willing to connect, it starts pushing. And these ones, they will not connect because they are not trying to connect to each other. One is trying to give, both of them are trying to give to each other. So we see, instead of the curve coming together, it will be splitting away from each other. They will be turning away from each other. So that's what happens in the system. I haven't spoken about the concept of magnetism. Some questions will pop up on your screen to test what you have understood in what has been taught so far in this lesson. The theories in magnetism. Of course, we know that it has been proposed, we spoke about this earlier, that in magnetism, it is believed that a magnet contains very many tiny magnets. So if you keep breaking a magnet into smaller size, you keep getting new magnets. This magnet will automatically generate new north and south poles. New north and south poles. And that's one of the theories of magnetism. So we have some particular properties, or should I call them materials, and their reaction to magnetism or magnetic fields. We have the diamagnetic materials. The diamagnetic materials do not, they are magnetic, they are materials in which a magnetic field is induced temporarily in them when they find themselves in a magnetic field, but they are non-magnetic. The kind of magnetic field induced in them is very, very small. How is this magnetic field induced? These materials have lots of electrons in their outermost shell, and as such, they have a lot of movements in their orbitals. So when this magnetic field comes within their range or close to them, the electrons in the orbitals are being aligned to flow in a particular order, but the order in the amount of magnetism that has effect on them is very, very, very small, such that they remain unmagnetized to the magnets. We see such situations in the case of mercury, carbon, and bismuth. Let's take paramagnets. Paramagnets are not so attracted to magnets. They are magnetic, yes, but they are not strong magnetic materials. The good thing about them is after the magnetic field has been taken away from their reach, they remain magnets for a while. They remain their magnetism for a while, longer than the conventional magnetic materials. Examples of such substances include aluminium, sodium, just to mention a few. Also, we have the ferromagnets. the ferromagnets. The ferromagnets are the conventional magnetic materials which we do know. They are attracted to magnetic fields, attracted to magnets. They have the potential of becoming magnets. That is, if they are passed through the proper way of making magnets, they can become a magnet. They are the ones that are used, they are the metals that can be converted to magnets. When they are not converted to magnets, they retain their magnetism for almost no time. That is, they lose their magnetism almost immediately. That's why when you put iron, you connect an iron to a magnet, it begins, if the iron becomes a magnet at that particular point in time, it attracts other objects to itself. But immediately you remove the magnets from the iron, every other thing connected to it also removes. Now, these ferromagnets are used in making magnets, permanent magnets, and temporary magnets alike. The Earth's magnetic field. Of course, we know that our magnets naturally have two ends, the north-seeking end and the south-seeking end. So this is actually, it shows us that there is a relationship within a geographical location, or within the cardinal points and our magnets. Our magnets are attracted to the Earth's field. The Earth possesses a magnetic field which is slightly away from the conventional. The Earth possesses a magnetic field which is slightly away from the angle of axis of rotation of the Earth. That is a bit different from the north-south actual thing that the Earth actually has. But it is this magnetic field that is but it is this axis that brings about the attraction between the north-seeking pole and the north pole, and as well the south-seeking pole and the south pole. It is this attraction that brings about the alignment of the magnets. When it is this attraction that brings about the alignment of the magnet when it is being tied to a string and held up. Of course, when a magnet is being tied to a string and held up, the magnet would keep turning until the north pole of the magnet is pointing towards the north and the south pole of the magnet points towards the south. Of course, our compass, normal compass, is a very good example of the effect, or is a very good example of the application of the knowledge of the Earth's magnetic field. There are some components that this magnetic field depends on. These components include the angle of dip, which is the angle of inclination. There are three components that the magnetic material depends on, that is the magnetism of the Earth. These include the angle of declination or the angle of variation. We also have the angle of dip, which is also known as the angle of inclination. And thirdly, we have the horizontal component of the Earth's magnetic field. Alright, let's talk about electromagnetism and electromagnets. Electromagnetism is a situation where a particular metal is being made a magnet due to the flow of electricity in the system. We have the selenium coil. So selenium coil actually helps us to induce a magnetic field out of electricity. Now, should a selenium coil be wrapped around certain materials as say aluminum or iron, and should be switched on, connected to a source of electricity, especially the alternating currents, a temporary magnet would be created within the period of it being on. This temporary magnet can find its application in many of our day-to-day electrical appliances. A very good example of such appliance is our electric bell. Our electric bell do work with the principle of electromagnetism. They have in the circuit it has something like this, and then metal bars. These metal bars are wrapped with selenium coil and connected to a source of electricity. Then there is a metal that holds the striker. The striker has a ball at the end, then the gong is there. Now when the switch or the bell is being pushed, electric current is sent into the metal bars, the selenium coil wrapped around the metal bars. So the selenium coil creates a kind of magnet that attracts this striker's rod. As the striker's rod is being attracted, the current will be breaking. So it will attract it and lose, attract and lose, attract, thereby making the striker to be moving forward and back, and it would strike on the gong, which is fixed to that particular point, and we hear our electric bell ringing. The same thing also happens in our microphone. Our microphones have part of it that contains and same thing that happens to our microphone, which have a part of it that contains a metal which is supposed to be replaced with a magnet. But we cannot use a magnet because we want it to lose its magnetism at certain times. The same thing happens in our forklifts. In some of our lifts, our lifting appliances, we have some materials that we use to lift objects, heavy machinery. And the part of it that will grab the object if we want to lift a container. I don't know if you've been to the wharf before to see how containers are being lifted. It drops a very heavy metal on the container, and then it lifts the container, and the container actually is dropped and the metal would leave again. During the period of it lifting it or making contact with it the first time, electric current is being passed inside the metal. The metal inside it has selenium coils. So the selenium coils initiate magnetic fields inside it. So the metal becomes a magnet and it lifts the metal. After lifting the metal, you want to remove, after lifting the container or whatever thing you want to move, you want to remove the magnet from the body of the thing you just lifted. So it only makes sense for you to use electromagnets in your operation of such machinery. Alright, in this lesson we've considered magnetic field, and we spoke about the concept of magnetic field. We said the magnetic field is the zone or the region within which a magnet's force is being felt. Magnetic field is the region in which a magnet's force is being felt. And we described the principles of the theory of magnetism that says that if you keep breaking down a magnet, it will keep generating new north and south poles. We also talked about the different natures of property materials attracted to magnets or influenced by magnets. We talked about the diamagnetic materials, that they are not really magnetic, but they are inside their structures. Their structures are being straightened or being controlled, and a magnetic field is induced within them. We talked about the paramagnetic materials, which are magnetic and have the potential to retain their magnetism for a while after the magnet has been separated from them. We also spoke about the ferromagnetic materials, which actually can be converted to magnets. They are magnetic, they are strongly attracted to magnets, and they can also be used for making electromagnets. We talked about the Earth's magnetic field, that the Earth has a magnetic field, which is what attracts the magnets towards the North Pole. The application of this is what is used in the construction of our compass. We also talked about electromagnetic materials, such as electromagnets and their properties. We said that electromagnets contain selenium coil wrapped around soft iron, and they are used for making different machinery, such as telephone headphones, microphones, and also we used the electric bell as an example for describing the modes of operation, and also discussed lifting machineries. Having talked about magnetic field, some questions will be popped up, will be displayed on your screen. So you are expected to answer them, and if there is any parts of this lesson which you do not understand, you can go over the video one more time. Thank you.